This was my very first contribution to OpenJDK. So the actual test will do the following. I will skip the first line. What we want to do actually is that we create an input stream and an output stream, right? And we then want to tell the input stream to push information, or we want to push information in the input stream, and we want to see what the output stream actually has done, right? So as we are not knowing what type of stream we actually have, well, we know it's some channel input stream and some channel output stream, but we could do combinations, right? So for example, what happens if a file channel is transferring to a socket channel, or vice versa? Or what is if a file channel copies to file channel? This test is modular in a way that it uses providers, and such a provider, I will show you where it is. Well, here, an input stream provider is something where I say create an input stream, and the input stream shall send these bytes. And an output stream is created with this method, and this method, wow, this is tricky. It gets something that spies on the input stream. So it's typed as a consumer of a supplier of a byte array. What's that? Wow, a consumer of a supplier of a byte array. So that means this thing actually is the consumer. And a consumer is something that gets something in his hands. And what it gets in his hands later is a supplier. And the supplier is something that gives something back. And this is the byte array. And why is it done that way? You can see it here in the usage. We have the input stream and we have the output stream, and the output stream is provided the spy, and the spy is a method which is called recorder set. And the recorder is an atomic reference to a supplier of byte array. So this set is needed to allow the output provider to store the supplier of the byte array in this variable, because from here you cannot write simply in a variable. This is not possible. You can only write in an atomic reference. This is because, for example, lambda expressions, if you're doing lambda expression and you try to write a variable, then it tells you cannot write a variable. All variables are implicitly final. And this is doing the trick of removing the final, actually. So what we actually have is a supplier to byte array. So what we do here is we tell the output stream provider, please give us an output stream, but we want to be able to receive the bytes later. So the next step is in the input stream. We skip bytes. This is a very interesting method. I actually didn't know it before. I learned it while I was programming this test, actually. Very interesting. We can simply skip bytes inside the stream to come to a position. So we don't need to read them, because reading them implies that we write them in the Java heap memory, while skipping them simply is discarding it. So this is not only faster, it's also reducing the memory load. And we're doing that because we want to come to the starting positions for those tasks that shall not start at position 0. And in the output stream, there is nothing like that. Unfortunately, we cannot say skip bytes in the output stream. So we have to write null bytes instead, which is we're doing here. So to come to the starting position in the output stream, we just write an array of this size. Next, we actually call the transfer2 method, which is what we actually want to test. So here's the input stream, here's the output stream, and we get back the reported bytes. And remember, we need to check not only the contents, we also have to check if the reported number is correct, because certainly it's nice to check that the content is copied, but maybe I did a programming failure and the result is wrong. So we have to check this also. And to do this check, we are asking what, or computing what the number of the correct output would be, which is the bytes actually in the input stream minus the starting position of the input stream. This is the count that has to be transferred, and we do assert equals. As I said, we are already using test-ng here, while the original contribution was not using test-ng. And if that fails, we just print out a failure message. And then we come to the actual comparison of the content. And here we have a first recorder.get, which again, this is just to get rid of the final that we cannot do. We cannot write from a lambda expression. So we do the recorder get here, and then we have the provider, the supplier, and the supplier, to the supplier we say get. So what we actually do here is we ask the output stream what was the recording. So the output stream is recording the content, and we get the content here. Again, this is so complex because we are not only able to test files where it would be easy to compare files. We also are testing with this code very complex types of streams, potentially complex types, like for example, blocking or non-blocking sockets. So this is in a future contribution, but the test is already done. And here we say assert true when arrays equals. So this is a high performance method to compare parts of arrays, which is really great. So I don't have to program that on my own. This is the bytes that we had in the input stream. This is the starting position in the input stream. And this is the end position where to stop. And the same for the really recorded bytes from the output stream. This is the starting position in the output stream, and this is the number, hopefully the same like this. So this is really great. Good tip from Oracle that I can use this one. And if it fails, it would print a nice message. So this is the test. And now you would ask, how do these providers look like? So let's see here. test-ng is providing us with a nice way to do matrix tests. So we provide a test matrix. And the test matrix is that first we're trying a file channel input with a file channel output, because this is the optimization that we actually are providing in this contribution. And second, we are providing any readable byte channel input to a default output. This is just to test the fallback. Here, the fallback. Why are we testing a fallback? Because Oracle said, well, Guy, if you're writing a test for this case, we don't have a test for the other case. Can you please test the other case too? Well, yes, I can. I'm running the same tests, but with a non-file channel input with a non-file channel output. So let's go first in the file channel. This provider looks like this. It takes the input of bytes, creates a temporary file, pushes the files in a single write into the file, creates a channel, an NIO channel, because remember, we are dealing with NIO, we need a channel. And then we say create new input stream. So this is the factory that provides the class under test. And the file channel output. Now this is the tricky one. We need to record the output. This is also creating a temp file. We're opening the temp file here in the write mode. And now it gets tricky. We set up the recorder. So when the test is asking the spy to get the result, then we do this code, which simply calls files read all bytes and returns the array. This is already an array. So this is really simple to do. The trick is only that you have to catch IO exception in case it horribly fails. And so we put that lambda expression into the spy because, again, the spy is non-writable normally because we're in a lambda expression, so we have to put it in some kind of wrapping holder, which is the atomic reference. That's why we call except here. And if we have given that handle back, then we go here to create the actual class under test, which is the channel output stream. The channel output stream was taken originally from Oracle. This is nothing I have changed. Also, the rest, everything besides this, was already given by Oracle. So what I did is just that I created the file and put the code here. This was an anonymous class previously. So now it's refactored into a standalone class. So we have a channel input stream here, a channel output stream here. This is created from a file channel. This is created from a file channel. So we can test the code that actually does the copying, the transfer from file channel to file channel. The other test case is the fallback, and the fallback just needs some readable input. So this is the provider for the fallback input. We just say create a channel input stream, create it from a channel, and create a channel from a byte array. This is rather simple, and we have a default output, which is way easier than the file output because no file is used at all. We just create a byte array output stream, which is able to give us a byte array when we ask for. So we tell the spy accept our solution here, and the solution is call 2-byte array on the input stream, and we report the output stream. 2-byte array on the output stream. So this is pretty easy. If you're interested in a real much more complicated test, there will be a new video when the next contribution is done. And one of the next contributions will be using sockets. And we will testing sockets with all other kinds of channels. So we will have a much more complex system of providers here for blocking sockets, for non-blocking sockets, and all that, and for combinations of that. So you will see this in action, and it looks like much too much for just testing files. Again, it's prepared for these complex tests, and in the next video, but possibly not in the next, but in one of next videos, you will see the extensions of both of this test and of the implementation. Well, that's it for testing. Okay guys, so much for today. This was my very first contribution to OpenJDK. You learned what the implementation looks like, what the performance numbers look like, how the test is working, Maybe you learned about JTREG and TestNG a bit, and you learned that you shall use the Files API to really get hold of this performance improvement, which makes your code copy bytes faster by the number of 2 to 5. And well, yeah, or use the Channels API. And watch the next videos for my OpenJDK contributions. I would be happy if you come back on the series of performance improvements for OpenJDK, and there will be more rather soon. I'm already in contact with Oracle about the next PRs. And what to say more? Yes, if you like this video as much as I did, and really I love this video, then please give it a big thumbs up on YouTube and tell all your friends about my channel. I really would love if all of them become subscribers just as you did. And well, yeah, visit me on the conferences which are upcoming now. And yeah, stay safe, stay healthy, and as always, a big party on, guys.